And all right, we're the Oxygen Reel. We're Team 190. My name is David Murphy.
And I'm Brian Wynn, and this is our prototype. So our problem statement, we tried to focus on more sick people, more people in need, and people who can't really muster the strength or mobility to handle long, extended, and tangled like oxygen tubing. And oxygen tubing is needed in a lot of households for older people. So we tried to make something that could sort this out and help aid this problem. We have a video to show it in action, which we'll show here.
Right now. All right, so that basically just showed the reeling and unreeling of the video. And to the next slide. All right, so now we're going to go over some of the components that are in our project itself, in our prototype. So the first thing I'm going to talk about is the limit switch, which has three settings: normally closed, normally open, and then the communication pin, which is kind of like the shared ground. And that's what basically determines whether or not our motor is going to be able to run. The way we have it right now is that if the limit switch is not being pressed, our motor will not turn. And this is for safety reasons, so that our users don't get their hands in there or anything like that. The second component is a 12 volt, 110 RPM DC worm motor. And the reason we chose a DC worm gear motor is for the added torque, because we found early on that it is quite difficult to rotate the reel if you don't have the right RPM and the right torque. Our initial motor had 280 RPM, and that just wasn't enough to cut it and rotate the reel. So that's why we ended up going with the 12 volt, 110 RPM. Then we've got our box, which is basically the casing for our reel. We had to drill a couple holes ourselves in it for the entry and exit of the oxygen tubing, which is the next component, the oxygen tubing. And that just basically allowed us to simulate kind of what it would look like in a real setting and when it's being used out in the real world. Then we had cable glands. One of the cable glands that went on the top of the box basically just controls the flow, basically making sure that no tubing goes in and out excessively, but still allowing it to rotate freely. That way there's no tangles or anything inside the casing. And then the other cable gland was located on the left side of the box. And that's basically where we just had to do the same thing, where you're basically not allowing it to go too much out, too far back in, while still giving it that rotational freedom. And then the next component is the L298N motor driver. This motor driver we needed in specific to be able to handle the 12 volt input and output of the motor. Otherwise, the L293D was just not able to handle the 12 volts. Next up, Arduino Uno. That's just basically where we ran everything from. That's how we got our code to program everything, etc. Our 3D printed reel, as you can see in the bottom left diagram, and our 12-volt battery that is also rechargeable, which was another hole we drilled in the box, the recharge port. And a key component with this battery was the 5 amps output, and that was just necessary to power our motor and make sure that it had enough to rotate the reel. And then the last component is the IR receiver and IR remote, which is how we kind of control the, extending and retracting just via that remote. So on to the next. So right here we got our circuit diagram. I'm gonna just start by just tracing each component to where they go. So I'll start with the battery at the bottom left. As you can see, the ground wire just goes to the ground of the motor driver. And then there's another ground wire that stems from that. And that's because you need to have a shared ground between the Arduino and the motor driver in order for this circuit to function. Then the power of the battery, as you can see, it goes to the 12 volt of the motor driver. Now our battery powers both the motor driver and the Arduino, but it only goes to the motor driver. The motor driver has a secondary output, this plus 5 volts, which we use to power the Arduino from it. So that's how that works. Then we've got our motor right above the battery. So it's just got its ground and power. It doesn't really matter where you plug these, but they have to be in the output one or output two. But the order does not matter. All it changes is direction. So as you can see, the ground in this case goes to output one and the power goes to output two. Then on the motor driver, we've got our input three, input four, and enable B. Now there's an input one, input two, and enable A on the other side, but I just didn't choose it because I didn't want it to be redundant. But the input three and input four basically change the direction of the motor, while the enable controls the speed. So hence the input three and input four go to normal pins, two and four, while the enable goes to a PWM, which is the five. So that's how we get our 0 to 255 speed. Then if we trace the plus 5 volts, it goes to our Arduino. Um, I'll talk about the IR receiver. Got our G, R, Y. Our G is the ground. Our R is the 3.3 volts power, and our Y is the PWM pin 9. Then our limit switch, this red right here is the normally open pin, which is the one we decided to use for our specific purpose. So that just goes to the 13, and then the ground, the C pin, which just goes to ground on the Arduino. So we ended up using all three grounds on the Arduino and pretty much every single voltage thing on the Arduino as well. So on to the next. I'll pass it over to my colleague Brian for the flowchart and code.
Yeah, so this is the flowchart. Essentially, starting from the beginning, if you press a button on the IR remote, the Arduino basically checks if the lid is closed or not, aka the limit switch is pressed or not. If it's not, then you need to close the lid and have it pressed in order for anything else to go through. From there, the IR receiver reads what the remote sends to it. Basically, our remote has 4 buttons total to control it. Basically, the rewind or fast forward button and the up and down arrow. For the rewind and fast forward side, if you press fast forward, it would dispense the tubing, while rewind reels in the tubing. The up and down arrow side, for up arrow, it just increases the speed of the reel, and the down arrow reduces the speed. And this is for safety reasons, just to not surprise anyone when they use it for the speed. Just to make sure it doesn't rip any oxygen tubing off of their faces or anywhere dangerous.
Yeah.
And um, for the code, starting from the top, we have all like the definitions as you saw in the wiring diagram earlier. We have all our pins into the Arduino. Um, for the setup, we basically just activate the IR receiver as well as all the other pins with the motor going forward and backward, and then the limit switch. And for the loop, basically it constantly reads for a input from the remote. And once it does, it basically checks the limit switch is set. If it's set to high, then the code won't run and it won't spin for safety reasons. But if it is closed, then it will start spinning based on your input. There's a slight delay just for safety reasons again. And then we have a switch case with the 4 buttons, the fast forward, rewind, up and down arrows. As you can see down here, 67 would be rewind, 68 would be fast forward, um, 9 would be up arrow, and 7 would be down arrow. And once it finishes its action, it will reset the cooldown and start waiting for the next button input from the remote. And yeah, that's about it for the code and our project overview. Thank you so much. We are Group 190. I'm Brian Wynn.
I'm David Murphy. Thanks once again. Thanks once again. Thank you so much.